So dynamic programming is another way or category of solving problems. So there are a set of algorithms that fall under dynamic programming, like how we saw first divide and conquer, then greedy algorithms, right? Now, similarly, dynamic programming is a type of solving methodology. So what is the difference, right? So there is the solution or how we approach the solution is very similar to greedy algorithm, okay? But there is a difference. So let's see what is the difference between dynamic programming and greedy algorithm. So let's first check greedy algorithm because we have seen that. What do we do in greedy algorithm? At each step, right, we have to make a choice, right? We have to make a choice which currently looks best, right? You remember what we did in greedy algorithm. We did the knapsack problem, or we did the job scheduling problem, right? So at that point, whatever was the best choice available, we picked that, okay? And that is always a locally best solution. It's always locally optimal or greedy. At that point, that is the best solution. But overall, when you see, right, it may or may not give you an optimal solution, okay? Greedy choice can be made first before solving further subproblem. So basically, you have to make a choice and then go ahead and solve the other problems. It is a top-down approach. It is simple and faster. Okay. Now, what is dynamic programming? Here also, at each step, you have a choice. Okay. But that choice is not just looking at the local optimal. Okay. You also look at local optimal. Okay. Say, suppose you have two choices at local optimal. Okay. But you also know what you solved previously, right? You have this history. It is like a memory. You know before what was the solutions that you did, right? Now you have a choice whether you want to choose the local optimal or you go back and see if your previous sub problems, whichever was optimal, you can have a decision to choose that as well. Okay. So at each step, the choice is determined based on solutions of the sub problem. Okay. So something you would have solved earlier, in dynamic programming, you can have an option of going and looking at the previously solved sub problem and picking the best option. Okay. So here all the sub problems are solved first. It's a bottom up approach, right? And can be slower or more complex. So now we'll see, and maybe if we do one problem, you will understand how this dynamic programming works. Okay. So to show, we have some examples. Okay. So first, what we will check is a multi-stage graph. So before solving the problem, let's see what is a multi-stage graph. We have seen graphs, right? We have seen directed, undirected, different kinds of graphs we have seen. But multi-stage graph has a certain properties. It's little unique by itself, okay? So what does it look like? So you will always have a source, okay? How can you tell it's a source? Because earlier we had this problem, right? You had like so many things. You don't know which one was a source, right? Remember in BFS, we had this problem. We can choose anything as a source and continue from there, right? But we call multi-stage graph as it has a proper source because always there will be one vertex out of which you will have edges coming out, right? This one vertex, it will not have any incoming edges, right? It will not have any incoming edges. It will have only outgoing edges. So such a graph or such a vertex is called a source vertex. Okay. So I'll give you one more definition. Say, suppose you have a vertex, you have something coming in and something going out, right? So I think we talked about this before also. There is something called in degree and there is something called out degree for every vertex. Okay. In degree is number of vertices which are coming towards it. So here in degree is 1. Out degree is number of vertices which are going out of that vertex. So out vertex is out degree is 3. Okay. Now in a source, in degree is always 0. Out degree it may have 1 or 2 or 3 or however, right? So such vertex is called a source. So it will all in a multi-stage graph, you will always have a source. Okay. And then say you have some vertices, okay, from which you will get some few other edges right? And then finally, all of them terminate towards a destination vertex, right? You see some property here, no? You have a source vertex because all your edges are coming out. And finally, you have a destination vertex whose in degree is some number, but out degree is 0. Right? So very clearly, you have source and destination. Right? This is one characteristic of a multi-stage graph. Now, along with that, there are a few other characteristics. What is it? This graph, such a multi-stage graph, can be divided into different stages. Right? Can you see here? Why do we divide? Why do I say that this is stage 1? This is stage 2. This is stage 3. This is stage 4. Because when you look at every stage, right, you have, okay, let's look at stage 2. Okay, so if you look at stage 2, you have a vertex, you have edges which are going out to a different stage, right? So if you look at any of the vertex, that's a characteristics of this graph, right? You look at any vertex, it goes from stage 2 to stage 3. There it is going from stage 2 to stage 3. Here also going from stage 2 to stage 3. You're getting it? Right? These edges always go from one stage to the next stage. Similarly, look at this one. This edge is going from stage 3 to stage 4. Right? So any edge here has a property where this vertex will be in, say, stage X, and this vertex will be in stage X plus 1. So you're going from one previous stage, right? You go from one previous stage to a next stage. And if you notice, no vertex is within the stage. Like you don't have any kind of vertex which is within the stage itself, like 3 going to 4 or 4 going to 3. You don't have anything like that. Right? You have no vertex within the same stage. Always always edges are from one stage to another stage. Okay. And finally, if you see, all edges start from the source, you go to different stages, and finally you culminate at the destination. Okay. So these are all different properties of a multi-stage graph. I hope you have understood what a multi-stage graph is. Right? It's just a graph. It's just that it has these different properties because of which you can classify them as different stages. Now, what is this problem here? What problem do we have to solve in a multi-stage graph? It's simple. You need to find this shortest distance from source to destination. These kind of problems we have seen before also. So what does this mean? This means you have a cost to these edges. Say you have some cost here, right? Say 3, 2, 6. I'm just giving some cost. 1, 2, 3. So you have different cost to each of the edges carry some cost. You need to find out what is the best way to go from source to destination. Okay. Now, if you don't apply, say, a particular algorithm, if you have to do it manually, how will you do it? You will do, say, pick one vertex. So suppose I pick from 1. Yeah. Let's pick from, say, vertex 1. Okay. You will pick, okay, say, let me pick this 3. Okay. I took 3 and I went to 4. Right. Now you have, okay, from 4, you have, okay, let me do one thing. Let me do different. So, okay. So now from 4, you have two options, right? You can either go to 6 or go to 7. So you don't know, unless you calculate how much cost it will take, you don't know. So you will try out both. First, you will try option 1, where say you go from 4 to 6, and then 6 to 8. You will try all this. 1, this is 2, and you will get some cost. Right? Similarly, you will. Okay. Similarly, you can try different other combinations. Say you go to 4, you go from 4 to 7, and from 7 you go to 8. Here also you have some cost. if you see, there are so many different possibilities. So this is one option, what you do. Now you can pick the other options because you don't see, here you can appreciate greedy versus dynamic programming. In dynamic programming, right, we will be evaluating all the possible paths, right? In if it was greedy programming, what you would have done, you would have started with source. Okay, you see, okay, I have three options. Let's say it is 9, 7, and 3. Greedy, what you will do, immediate, what is the choice? So you will pick, okay, 3 is the best choice. You've decided that looking at this local, I have 3 as my best choice. So in greedy, you will always pick this path, right? And secondly, you will see, okay, here, what are the possible options for me? I have 1 and 2. Okay, you will think, okay, this is the best choice for me. 4 to 1 is always, because that's a locally best, right? You will go here, right? But say for, let me, I think instead of 2, right? Let's say the cost is 12. Okay. Or say let the cost is 120. Okay. Now you will see the problem. In greedy, what we will do? We will say, okay, from 6 to 8, what is the possible route? There is only one possible route. So this is the best solution for me, right? This is what greedy would have done. But overall cost, if you see, it doesn't lead to optimal, because this itself, the last choice that you made was very wrong, right? So here the cost, overall cost will be something like 124, right? So that is why the greedy problem will not lead to an optimal solution. But how dynamic program works, you check all the choices, right? So you evaluate everything, 3 to 6, 6 to 8, right? Then you see, okay, 1 to 3, do I have any other option? No. From 3, do I have any other option to 6? No. Okay. So we are done with, so these two, where with 4, I had two options. Now I'm done with the option 2, 3. So similarly, you will evaluate even for 2. I pull it to, here is this. I hope you got understood how the problem with, what is the problem with greedy algorithm here, right? So in dynamic, we have to evaluate all the possible paths. So we did this 3. So we did with this 4 vertex, we did with this 3 vertex. Let's do with 2 vertex. So we have to check this also. Now again, here you have two choices. So let's pick one choice. 5, right? 5 to 8. I have this option also. 5 to 6, 6 to 8. Right? Any other choices we have? I think not, right? We have covered all the paths. So if you see, you have path 1, 2, 3, 4, 5. So you're evaluating all the paths, okay? And then you're choosing whichever is the minimum cost. Okay, so if you see greedy, dynamic programming actually goes ahead and uses what you had computed earlier, okay, and it will build the eventual solution. Okay, with this explanation, let's pick one problem from your textbook and try to solve. So only thing is, this will be a little, this is how you do, okay, like how we did here, right? You will basically have to find out all the possible paths and finally check whichever cost is minimum, okay? The method is very simple, but because we are going to try all the possible paths, it's going to be a little longer, okay? Just need to, maybe if you practice 1 or 2, you will get used to this. There's nothing complex here. It's just that it's going to take some time to solve it. Okay, let's pick one example. Say from a textbook I'm picking. See if we can. I'm just taking a pic and sharing it so it's easy to. Let's try to solve this. Okay. So what we will do is there are two approaches. Okay, one is backward approach. Backward approaches, we will start from here. Okay, and we will go back and try to calculate this path. Then we will go back to this stage and we'll try to calculate the path. And finally, we'll go back to this stage and we'll try to calculate the path. So this is called backward approach. Okay. So what we will do is, because we will do, first of all, you identify what are the 4 stages here, right? Right? These are the 4 stages. We try to solve this problem first, because when you want to solve the stage 2 problem, you will use the solution. You know that, okay, I need to calculate only what is the cost from, say, stage 2 to 3. From 3 to 4, I already would have calculated, right? Similarly, when you come to stage 1, you only need to calculate the cost from 1 to 2. And then from 2 to the termination, you know already, you would have previously calculated. We will reuse that, okay? So let's try to do this. So what we have to do is just the terminology, let us understand. We have to find the cost, okay, from, this is stage 4, stage 3, stage 2, stage 1. So we said that we will do a backward approach. So first we have to do this cost. So what we will do is we will find the cost from all the vertices in stage 3. Okay. So here we are going to call this stage. Okay. And here list of all vertices. Okay. So here we have to calculate from stage 3. Okay. And the list of vertices are 5 and 6. So what we will be doing is we will find out the cost from stage 3 and from vertex 5. Okay. We also need to calculate the cost in stage 3 from vertex 6. This terminology is clear, because sometimes this gets confusing, because we have seen in earlier problems, this means vertex 1 to vertex 2, right? This is not vertex 1 to vertex 2. The first one, this part represents the stage number. Okay. And this actually represents all the vertices in that stage. Okay. I hope this convention is clear. Okay. And what this means always when I say from stage 3, I use vertex 5 to reach always your termination, your destination or terminal. Okay. No, this is what it means. So what you have to do, you have to actually find the cost. This cost you have to find. Right? So you're picking stage 3. Okay, you are picking this vertex 5. Now you have to find the cost from 5 to 7. 7 nowhere you are giving, because that is fixed. You know always your terminal is 7, right? This is well known. So nowhere in this representation you will say 5 to 7. When you say 5, you understand that you are trying to find a cost from 5 to the termination edge. Okay. So here, what is this? This is very direct. The first stage is very direct because there is only one vertex here. So this cost is 7. And what is this cost? This is stage 3, vertex 6, cost is 6, right? So we are done with first stage. Now we have to calculate stage 2, right? So what are the, we have to try basically all the vertices. So how will you do this? You have to find the cost from stage 2. Let's pick the vertex 2. Okay. You have to, this is, so basically cost from stage 2, and here vertex is 2. You also have to find the cost of stage 2 with vertex 3, and you have to find the cost of stage 2 from vertex 4. Okay. And what cost you have to find? From 2 How do you go 7? That's what you have to find. Okay. In between, you can pick any of the previous costs. Okay. So how do you find this cost to 2, right? So the cost to 2 is the cost from going from 2 to 5. Okay. So what do you have here? You have different, you have to take, you don't have a direct path, right? You have different paths. So what you have to do, you have to find whichever is minimum. What is the minimum? Minimum of cost from going from 2 to 5. Cost of, okay, this I will put it as C. I'll tell you why. 2 to 5. And so this is the direct edge, 2 to 5. Plus, you know that cost of going from stage 3 to stage 4, right? Plus cost of going from stage 3 vertex 5. I hope this is clear. I'll just pause here. Just see, try to understand. I'm trying to get the cost. What is the cost of going from 2 to 7? Okay. One is I have direct edge. I have to pick that. Okay. So this is the direct edge. And because this is edge, right? The convention is different. I have not put cost. I've used something like C. 2 to 5 means it's a direct edge from 2 to 5. This is what it means. It doesn't mean stage. Like here I said first is stage, second is vertex, right? This is different. C means different. It's a direct edge. And this one is the cost. Okay. Is this clear? Because if you are clear with this only, the rest everything is based on this understanding only.
Ma'am, one more time, ma'am.
Okay. This see here we are trying to solve stage 2 problem. Sorry, stage what? Yeah, stage 2 problem. This was stage 3. Did you all understand stage 3? Because this is very straightforward.
Yes, ma'am.
We said this is a backward approach. So first we will do from reverse. Stage 3 to stage 4 always will be your direct edge, right? That is why this is 7. Sorry, how did I get 7? This is 5. And this is 6. This is the direct cost. Okay. And whenever I say cost, these two numbers, you need to understand what this means. And whenever I say C, two numbers, there is a difference. Whenever I say C, it is a direct edge. Whenever I say cost, it means first number represents the stage. I'm in stage 3. And in stage 3, I am checking vertex 5. That's what it means, right? And here, because in stage 3, you have two vertices, you have to find out two different costs. Basically, you're evaluating two possible ways of reaching the terminal. Okay. So the stage 3 is clear. 3 means stage. I'm evaluating 6 vertex. So I'm going to find out what is the cost of going from 6 to 7. This is a direct cost. This is what I put here. This is clear. No? Stage 3 is clear. The first step.
Yes, ma'am.
Okay. Now coming to the previous stage, because this is backward approach, we are done with this. Now we are going from here, right? So what it will say is, how do you go from stage 2 to the terminal? You have to go from stage 2 to stage 3, and from there only you can go to terminal, right? So that is why we say that first you have to go using a direct edge. You have to pick one direct edge, and from there you can pick other paths. Okay. So first you have to pick a direct edge. So I know that from 2 to 5, I have a direct edge. Okay. Then from here, I'm reusing this calculation. I will say, okay, whatever is the path from going from this third stage, fifth vertex to the terminal, right? Just reuse that. I'm not going to calculate this upfront. I'm going to reuse. Okay. So now you tell me, what is this cost 3, 5? What will it be?
To reach the terminal, ma'am.
Correct. See, correct. So from, and this one, because it's backtracking it, you're going to reuse the sub solutions done in the previous step. Remember, in backtrack, in dynamic programming, we will reuse the solution done in previous step. So this one I have already evaluated, right? So you know what
Yes,
is
ma'am.
this? This I know it is 5, right? And what is this? C2, 5 is edge. What is the cost of this edge? It's a direct edge, 2 to 5. What is the cost of this?
2.
Okay. This is what you need to understand. The first one will be the edge. The second one will be what you have previously calculated. Okay. So this cost is what? 7. Okay. This is one option. We are evaluating from 2 to reaching to terminal. This is option number 1. There is another option, right? So you can go from 2, you have one more that you have to evaluate this also. So you will say the cost, direct cost from this 2 to 6 edge. Remember, this is edge plus whatever was the cost from going from the stage 3, 6th vertex. So this is stage 3, 6th vertex. Okay. So what is this? 2 to 6 is, can you find out what is the cost here of this edge 2 to 6?
Four.
Correct. So the cost is 4 plus this one. Remember, always you would have done it before. You don't have to redo it. So what is the cost? 3 to 3, 6? 6. Right. So the answer is 10. So we said we have two options. Whichever is minimum, we will pick that. So which one was minimum?
7.
Right. So you have to remember this one. Okay. This was minimum. Okay. So that's how you do this cost. So we have finished evaluating the second vertex in the stage 2. Now, same thing you have to do with stage, the other two vertices, 3 and 4. I'll be running out of space, so I'll just keep copying this problem, the diagram here, so I can easily. So let's try to do cost 2, 3. Okay. I'm trying to do this cost 2, 3. So what is cost 2, 3? So I'm trying to evaluate. I'm still in stage 2. Okay, this 2 means stage, right? I'm in this stage. And I am evaluating the third vertex. 2 we are done. So now I'm evaluating the third vertex. So I have to see all the direct possible edges and what is the cost of going from stage 3 to stage 4. That's what we have to see. So whatever is minimum. Okay, we may have more than one option or we may have just one option. We'll see. So first one is the direct cost. Direct cost from 3 to 5. So remember, this is edge. Okay, plus cost of going from this stage 3 vertex 5 to the destination. So how do I represent the cost of going from stage 3 vertex 5? Right? This I know 3 to 5 is direct. Always remember this, you don't have to calculate. You would have done it before. Right? 3 to 5 is 5. So this is 11. Any other possible option we have from 3? We have this, right?
Yes, ma'am.
So you have other option. So you have cost of direct edge 3 to 6. This is again edge plus cost of going from this stage. So we have stage 3 vertex 6. This, this is what 8, I think here. I don't know if it's 8. No, 8 is
3,
for this.
ma'am.
3. Yeah. 3 plus this, remember, you don't have to calculate. You will get it on top. 3 to 6 is 6. So this is 11, this is 9. So remember your choice. We have whichever is minimum we will choose, right? So you chose this one. Maybe you can just highlight what was your choice. And here also we chose this choice because this is minimum. Okay. So are we done with stage 2 or we have something more left? We finished this vertex. We finished
No, ma'am.
this vertex. We have to evaluate this vertex, right? Very similarly, let's evaluate this vertex. We have to do now what? Cost of the second stage. We are checking this one. So second stage, and now I'm checking fourth vertex. Right? So what is this? There could be multiple options. We have to choose whichever is minimum. First option is, yeah, I have this option, right? So it is C. That means direct edge from 4 to 5 plus the cost of going from stage 3 to the destination, to the terminal. So stage 3 via this vertex. The other option is what? 4 to 6 I have plus the cost of going from stage 3 vertex 6. Okay. This we know 4 to 5 is 8. This we don't have to calculate. It will be somewhere on top. 3 to 5 is 5. This is 4 to 6 is 5. This again, you don't have to calculate. It will be on top. 3 to 6 is 6. Right, so this is what? 30. This is 11. So this is the minimum choice. So we'll just keep this marking. Okay. Right. So with this, we are done with second stage. Sorry, not seconds. Yeah, second stage. Okay. So now we are left with stage 1. Let's do that. Okay. So now, how do you do stage 1? So you are doing the stage 1, right? So how many choices you have? You need to find the cost of stage 1, and there is only one vertex here. Okay, so 1, 1 only you have to find. So we'll see how many we can have more than one choice. Now we have to calculate cost of 1, 1. So we are in stage 1. In stage 1, there is only one vertex, so we just have to evaluate this. So what is cost of 1? 1 is the stage 1, and this one represents the vertex number 1. So what is this? Here, if you see, I have 3 options, right? So I will have 3 options. So first one is the direct edge cost 1 to 2 plus the cost of going from stage 2 vertex 2. Okay, this is choice number 1. I have another choice, cost of going from 1 to 3 direct edge plus cost of going from stage 2 vertex 3. And I have a third choice also here, cost of going from 1 to 4 plus the cost of going from stage 2 vertex number 4. Okay. These are direct costs. So you know 1 to 2 is 9. This you don't have to evaluate because you would have done it before. Let's go up and see what is cost 2, 2. Where is 2, 2? Here. You see? 2, 2 was what? That's why I told you to highlight. Because 2, 2, we chose
7.
7. Right. So 2, 2 was 7 for us. Right. So this cost is 60. Right. Now what is this? 1 to 3. 1 to 3 cost is
7.
7 plus what is cost from 2 to 3? Let's go up and check. 2 to 3 was
9.
9, right? 2 to 3 is 9. So this is what? 16. And let's check this one. 1 to 4 is 3. Plus this we don't have to evaluate. It will be on top. 2 to 4. Yeah, 2 to 4 was 11.
11.
So this is 14. So which one is minimum in this?
14.
Right. Okay. So we are going to choose this. Okay. So we are done with stage 1. There's no other vertex to evaluate, right? Only one vertex. So finally, what is the path? Which path are we going to choose? So now you have to build it, right? So you're going to choose this 1 to 4. Okay. Plus, so 1 to 4. Let me highlight it. This one. 1 to 4. Okay. This we know. Then from here, how do you go? You have to go back. Cos 2, 4, how did you get? You got by going toward from 4 to 6,
4 to 6.
right? So this one. Right? So you got it right from 4 to 6 plus 4 to 6 and then cost of 3, 6. So go back and see what was cost 3, 6. 3, 6 was directly this edge, right? 6. So that is this one. This is 6, 7. Right? That's how you get. You see, now you can reevaluate it. It is 3 plus 5 plus 6. Is it matching to 14? Correct, no? 14.
Yes, ma'am.
Right? So this is your path. This blue highlighted one is your minimum cost of going from source to terminal. Right? Is this clear? Right? Now, how do you know what is the final cost? You have to build the path, right? That is a problem statement. You need to find the minimum path from source to your terminal. So what we do is at every step, we have highlighted which path we chose. You remember we colored this yellow coloring, what we did, which was minimum, right? So we are going to use that coloring to trace it back. Okay, so let's start with this. This is a direct edge. C1, 4 means a direct edge, right? That is C cost of 1, 4, this edge, right? After that, it is some path. Whenever I say cost, it's a path, right? So how do you get, you cannot say directly from here, you don't know which path you would have chosen, right? So you should go back and go back to how did you evaluate cost 2, 4? How did you evaluate cost 2, 4? You said this is the minimum. So you pick this edge, right? You pick this edge, cost 4, C4, 6. That means this edge you picked, 4, 6. And then there was some path, right? You know that this direct edge you picked, right? Whereas this is some path, you don't know what that is, right? So you go up and check again. How did you do cost 3, 6? How did you do cost 3, 6? 3, 6 was a direct edge, right? When I say 3, 6, it is not from vertex 3 to 6, right? This is a cost. So it is in the stage 3, vertex number 6. So this is stage 3, vertex number 6. So this path you have chosen. Understood how you got this?
Yes, ma'am.
Yes, ma'am.
Right? So this edge. This is how you finally use your solutions at every step that you did and you build your final path. Okay. I hope this is clear.